You know, what I was thinking is that if we are going to change that Python to be a continuous streaming of the continuous streamer, then we will have to modify also the big script, right? Because the big script is not a string reader, right? Right now we are using just the load. And
right, see, that's where a little bit, you could go to a stream like that, but you'd have to
do modifications
to accommodate for Sergio's point, which is absolutely true. PIG is intended for a batch environment. It's not intended for a streaming environment. You wanted to take the same example and do it in Scala on Spark, that's the right place for it. Use Spark streaming instead of PIG.
Yeah, but
You're the Scala expert.
For that you will have to open sockets.
You're the Scala expert, right?
No, I'm not. I'm just waiting for it to be for Dan to teach us that.
I remember 3 weeks ago you said you studied Scala.
Yeah, I started, but I didn't finish it.
Okay, so keep it. So Sergio's point is really good. If you're gonna try to do a live feed, you're gonna be in a streaming environment. And PIG is not intended to work with streaming. It's intended to work with files. It reads the entire file. That is not hard, obviously, to just take a Python script and set a file size or number of lines that you write, whatever criteria you want, like number of lines, let's take it that way. And say every 2,000 lines, Python is just going to start a new file. So you're essentially taking the stream data and sending it one file after another, 2,000 lines of the file, and Flume will pick it up, find the PIG script will process it just fine. But you may want to do something more interesting on the back end and have PIG look at the aggregate of the files, not just a single file.
Okay.
So that would be an interesting way of doing things.
Well, I'm sorry, when you say look at the aggregated files, what do you mean by that?
If we turn off the sharing here, if we do a continual stream over here, and we say that the logic in the Python is such that, I'll put this in black for the additional information being added on this segment. We said here that for continuous, let's assume continuous on this side. Since PIG is at the other end, it's file-based, it can't take a stream.
Right.
You'd have to take the continuous information and...
Because right now we have it as continuous. Python is continuous right now.
Well, Python is continuous. It's continuous in the sense that it has this sleep condition in it. And I'm talking about continuous over here. We have continuous input from RS feeds, like for Twitter, continuous. We have something continuous coming into Python. Python doesn't even need to sleep. It's just going to keep working.
Right.
So, you have to take the sleep out or put in some extra code around it. And then also need, for the purpose of being able to support the PIG on the other end, we need to start a new file every 2,000 lines, or actually more like 10,000 lines would be better.
This file is, you're talking about the existing file?
Yeah, what he's saying is to create every 10,000 lines, create output 1, output 2.
Change the current, the Python file,
so
right?
on.
Yeah, it's create a new one. And obviously you're going to fill up your directory here if you don't have some way of purging out the old ones. And it's probably Flume may have the configuration to do that, because if you remember from their Flume lab, Flume indicates that it processed the file because it'll take output.csv and go .completed. That's how Flume knows that, okay, I'm done with that.
Right.
And if anybody as an engineer needs to look at the whether the file is actually processed, there's still a record of the fact that it was processed. So if Python's looking to if you have a separate script running to clean up your directory, you're going to be looking for .completed files to remove.
Right.
So if in a commercial environment, I mean, we're describing exactly the stuff that I used to work on. I mean, at some point, the disk fills up, and you got to have some purging mechanisms so you never actually hit that point that the disk filled up.
How often are those RSS feeds that you gave us updated data? Do you have any idea?
My impression during the weekdays when I worked on this was hourly. So it wasn't, I don't think it was even half hour or 15 minutes, but I'm pretty sure these are hourly. But weekday.
So at the even hour,
Yeah, every hour.
every hour.
Yeah, and I don't know if that included the nighttime hours. Like
You know,
10
when,
PM
yeah,
to-
so when we say hours, it means 7 o'clock, 8 o'clock.
Exactly.
It's not like 7:15, 8:15. It's the even number, right?
It was right on a boundary. It had
Right on
a
the
reasonable consistency. And this is a while ago, so I don't remember exactly whether it was 8:05 or 8:30 or 8 o'clock.
Because actually, in the very first context, what we can do is just go ahead and process the very first output that we get, process it, remove it, and then within an hour or so, sleep for a little while in our big script, and then go back and check if the output.csv exists. If that exists, then we wake up and we process it, we delete it, we go back to sleep, and we continue like that forever.
Yeah.
Instead of doing, because in this case, it happens every now and then, and it's not really continuous data, so I don't know.
Right. So there's continuous and not continuous.
Exactly.
Yeah. And both of these are different models. Continuous. So here, it's more, well, what's up here is for the not continuous. Let me just select
Right.
this. So rewrite it. If you're going to do it continuous, you're going to have to you take out the sleep and you'd start a new file like every 10,000 lines. And what would be interesting over here is to have big provide summary, for each hour, and maybe aggregate summary. So there's an aggregate summary for the day, and for basically summary of counts per hour, counts per hour, and then summary of counts for the day. I'm sure there's some type of lexicon out there that is a listing of all the little, the small connecting words like is, or the small verbs as well, is, the, to, and all that. I'm sure there's some type of lexicon out there that can strip all of that out. And then you're left with something that's interesting. So here's an opportunity to be creative.
Yeah.
You mean the pig is after the Python get the file from the HDFS?
A pig right here, this Python script, it invokes the pig script. So this is looping through here. It's gonna.
And then this pig script is the one you just mentioned.
Correct. In black here, that's the pig script.
Okay.
So this would loop through like this. It goes through a couple steps here, and then calls the pig script again. There's a sleep in here. Calls the pig script again, there's a sleep that needs to be balanced right there. This is a lightweight version of in a Hadoop environment. For the last product that I worked on at Motorola, we were loading 16 million data records every 5 minutes.
No kidding. Wow.
So it was.
And why so much? Why?
Because we were loading performance data.
Oh, okay, inside data.
So this is dynamic performance data of call failures that happen there's also successful calls. That
So it's just call records
in the system, right? So we were taking in only the 6 records used to count call failures. Those are 6 different types of failures that the Motorola system tracks. So that we would get those counts from every single sector carrier, if I can use that word. So the sector carrier means that if I have a 360 degrees of coverage, every sector is 120 degrees. And I could have like multiple frequencies set up to cover the population density. So I could have like 30 sector carriers covering a certain region. So I'm going to get data records from every single one of those individual sector carriers every 5 minutes across the entire country of Japan.
Well, these were RF call failures, just at the RF level.
These are all RF.
Okay. Sorry, I'm being a nerd.
Yeah. So we would get the target for the customer's projected network growth for 4G was that we had to be able to handle 16 million records per 5 minutes. So it took a lot of redesign as a technical lead to make sure we could do that and accomplish it. By the time I left, the day before I got laid off, it's like, okay, it's done, signed, sealed, delivered. but we were tight enough on the schedule where my boss is like, no, I can't let you off in May. We're not done yet. So he pulled some strings and got me to stay a couple of months later, a couple months longer.
You should have asked them to hire you as a consultant.
No, he was smart for doing that. I know what, as soon as you do that, they take away your funds, your fun funds.
Yeah, you can't go back. I'd rather take the severance package and be done.
Oh, yeah.
And if you're a consultant, contract doesn't matter, they cut those funds off. No double dipping.
Yeah, so that, when I'm talking about stuff like this, we literally had this is ETL essentially, but there's not a lot of transformation being done in here. This is more like dump the data in and let Pig crunch on it. So this is a normal flow to go through. We had our sources, as I described when Sergio was talking there, that was essentially continuous. So it's a constant 24/7 operation. And then we had, instead of Python scripts right here, we had Java programs that would bring in the files.
Java can handle that?
Yeah. Well, we had, I think it was like 30 loaders, Java readers actually, running at the same time. I mean, we had a pipeline of proportional volume of data that could be handled. We'd have about 30 readers running at the same time and 30 loaders running at the same time, things like that. So as we walk through this, we were generating an output file like this, and then we were using, we weren't using Flume because it was a relational database environment. And then we had a file similar to Pig that would be generating the SQL so that we could load the data into the database. And once the data was in the database, then there's aggregation on an hourly basis and a daily basis.
So that means if we have a Hive there, that we don't need to use any of those. After.
Yeah, the difficulty though is that Hive is for analytics. It doesn't have strong capability to clean the data if the data is messy. So if it is perfectly clean data coming in, like what I just described on our project, because it was relational database oriented, yeah, we could use Hive.
Yeah,
In
but
this case-
after you got the output file, the CSV file,
Right, it's,
and that is kind of like already formatted, right?
it's kind of separated.
Yeah. And then with the column as the same data type.
Mhm.
And then
Yeah,
if you feed that file as an input to the Hive, and then
right, so Hive would first have to load it in order to do anything with
Yeah.
it, because it can't process it.
Yeah.
And then after it's loaded, then it could do.
and then you do query, and then you
Right,
got
then it could
everything.
do the equivalent of what this big script does over here.
Yeah.
Okay, so from an analytics processing perspective, Hive and Pig shadow each other. They just have a different way of doing the same thing. And what underneath both Hive and Pig is the execution environment of MapReduce. So Hive and Pig are hiding the details of MapReduce so that you don't have to write a Java program to do the processing that's under the hood for Pig and Hive. Okay. So the only reason why Hive exists is because it's a low barrier comfort. You know, it eliminates the barrier of discomfort working with Hadoop. There's plenty of people out there in the marketplace that are familiar with SQL. So if you throw SQL out there and say, hey, here's an interface, which is what Facebook did because they're the ones who provided Hive, then it lowers the barrier to people, technical people, becoming comfortable with big data Hadoop environment quickly. So Hive's there, come on. You already know how to use it. A little bit of wrinkles here and there. It's not going to be perfect, but it's pretty darn close because it's not anti-SQL.
Yes. Okay, so this sounds like a really nice project.
It's,
Tony will have it ready by Wednesday.
Just don't give me the date.
Wednesday, 2 weeks from now.
Yeah, 2018.
All right, let me double check everybody's on there. So Yukiko's on, Ganesh dropped off, I guess, or he's not joining. All right, good. So let me go back over to the Hive space. All right, so we have this slide that we ended at last time. There were some preceding slides. We're going to be stepping through this, but let me just roll through the preceding slides quickly. Because I already looked at them. All right, so this is Hive starts on page 97 in your course notes. But just from a perspective, since we were talking about Hive versus Pig, you know, how do these work out? So very quickly, Hive is the SQL interface, as we know. Purpose is data summarization and ad hoc queries. And this is the primary thing, actually, is analysis of large data sets. So it's not the right tool to use for cleaning the data.
So when you say Hive is not a database, I heard right now that some companies start to use Hive to replace the data warehouse.
Yeah. So, all right. So let's put the picture on the board today that we had last week to cover this architecture point that Joe was bringing up. This will also be like, okay, what did we say last week? Do we remember? Okay. So this idea that Hive is a data warehousing infrastructure, let me go through.
Okay, here it's mentioned.
Right. So when the emphasis here is that it's an infrastructure. It's not a single point solution. Right. We'll do the diagram, but let's go through a couple slides. So it says it's not a database, it literally is not. It's a collection of databases. At the, if you were to boil Hive down to its minimum description that is maybe oversimplified, you'd have to say it's a collection of databases.
Collection.
Or a collection of data files, more technically. Combination of data files / database tables.
So it's, the key here is files, there's not a lot of relation, it's no structure or a,
It has to be
It is
structured.
structured.
well, it's structured, but it's not.
It's not stored in a way that a SQL engine.
Right, that's
process
it, okay,
Yeah.
that's, I'm missing the word, I'm trying to,
So the Hive actually is the
they're structured.
higher level of abstraction.
Yes. And we'll see that. All right, so Fig versus Hive. Fig is where you're changing the data. You know, we saw that through the fact that the schema is applied after the data gets read. So Pig is all about data transformation, meaning adjusting the schema, creating new relations, whatever you need. And then Hive is into the space of ad hoc query, or ad hoc makes it sound like it's never seriously commercially used. So there are regular Hive scripts that run that do analytic operations. So ad hoc as well as batch SQL processing for analytic purposes. Exactly the same as what it's done for data warehouses right now.
The query, actually you do a select, right? And then when you select, you pick portion of the data you need.
Yeah, and what you said is what's true for relational database as well. So
Yeah.
you said a really key thing there. Okay, and I don't know if it's in here on this listing, but what Joe said is really important to understand. Pig reads the entire file.
The Pig, you also have the choice. You read the entire file, but you can also pick up whatever you're interested, and then you skip whatever you don't want to.
If you follow exactly what you said, yes. Hive does not have to read the whole table first to pick out what's needed. You can treat Hive as though all it does is pick out the records that you want. The rows of the tables that you want. You don't have to, behind the scenes, there's some optimization with regard to structuring that table so that it's got reasonable performance. But Hive does not require reading the entire table of data in order to find and process the couple records that are needed. I mean, that's not part of the language. The engine of Hive allows you to just grab the 2 or 3 records you need without doing a load command. You don't need a load command.
Yeah, because it's is already loaded for the Hive, right?
Yeah.
It's already in the table format.
Yeah, and exactly. And that statement's true for Oracle databases as
So
well.
that's why the Hive just do a query and then pick up whatever it needs.
Right. It's already been loaded through some other means, through Scoop or through Pig or any one of a couple of other means that can populate tables.
So Hive is just a lazy version of
What
Pig.
do you mean by the joint?
In one sense, that's very true. Hive is a lazy version of Pig.
What do you mean by joint distributed? Is that a middle of the, yeah. What is that trying to say?
Well, it just means that if tables are stored in several different
You
locations.
can do a join, it may take some time, but
Right, because it's not like a relational database that's got a lot of.
that's what I was trying to get
It's
at.
not
that
distributed.
Yeah, well, can't you distribute the new Oracle? But now, a single table cannot be distributed.
Not across multiple processors, heavy.
So I was thinking across disks.
Yeah, the distributed in this case is going to be across processors. Think of it more in that sense.
Oh, okay, that's cool.
All right, so shell streaming, so Pig and Hive, they both support streaming in some sense. I would have to look at the streaming here to see if what they mean by streaming is the stream operator
No, streaming actually,
as opposed to a streaming data flow.
my understanding is for the UDF, you can only use certain type of
Yes.
language. For the streaming, you can use any kind of language.
Mhm.
And then you define as one of the function and then stream into the gig or stream into the high.
Okay. So I'll do some looking on that. This is to see what the streaming is. I think, I hear what Joe is saying.
For example, you can use the seed and arc as streaming, but you can now use seed and arc as a UDF.
Right, so I've read about Awk, so they can use Awk as from a streaming perspective.
As a one line. So you get very powerful stuff
They're
when you do streaming.
Set and Awk are pretty much pairs go together.
Yes, second, yes.
And they're saying set or sit.
Set,
Set, SED.
SED,
Right.
set and arc.
Yeah.
Right now,
They're both three-letter words.
right now it's not that popular, right? Before it's
No,
so
it
popular.
seems to have died out. I don't know, but it's the nature of the beast.
Okay, so UDFs is user-defined functions. This is part of what I want to touch on today because Joe already has an example now. What could be one line.
Actually, my example, I don't think I shared.
You sent it out an email.
The one I sent out actually is a standalone. It's kind of like today what we did.
Okay.
Actually, I have a version of the UDF that is registered and then called as part of the gig. I think it's in other computers, not on this computer.
So,
I can send it out later.
yeah.
But I mentioned partially like only run one line. That will be the UDF.
Yeah, I saw that in the email in particular.
Yeah.
Okay, so the idea of Hive is that you also have partitions. So what are partitions used for? This is something in the exam in Caldera as well. You gotta know what partitions are used for so you can recognize a scenario that they throw at you that would require a partition.
To separate data by categories.
Right. So that's functionally what it is, but for what reason? And why do you need a partition?
Probably to better use resources. In this case, the hard disk memory space, for instance.
That's not gonna be a space issue.
Is it related to the traditional database concept?
Yeah, it's the same as the traditional database.
So the purpose would be to have big tables spread on different drives so that you can access them probably in parallel and speed up.
Yeah,
For the performance.
It's a performance issue,
For the performance.
right? And specifically, the specific performance scenario is intense writing and seldom reading. They occasionally need to read, but I'm constantly writing. Those reads are going to get blocked, even though they're not happening very often. The writing has control of the system. So that's the example I mentioned where we're writing in, we're taking in 60 million data records every 5 minutes. We had to take our partitions down to, I don't remember if it was a 10-minute increment of time or 15-minute, it was right around there. Because the performance was horrible at 30 minutes worth of data in a partition. So our need to read the data collided with the writing activity still ongoing into that same partition. So whenever you see the word partition, translate it into your mind as, oh, that's a new file. It's a new separate file. That's physically what it is.
Separate file.
Right. Even though it's a table, that table gets broken into a new separate file. In Oracle language, you'd call it a new segment. In Hadoop language, it would literally be a new file.
In the Oracle world, that means still the same table. It's a big table, but just different segment on different disk.
Yeah.
Might be in the same disk.
Yeah, it could potentially be on the same disk. It's
just different
Can-
block, whatever,
Right.
In order for you to do a parallel processing.
right. Okay, so partitions are important. So this is a good checklist here.
It's cool.
Okay, so did we get, this is the second time through this. I find this interesting when we go through this because there's a little bit of discussion the first time through. Then the second time through, there's a rich amount of discussion, which is a positive thing. It makes it a little harder for me to figure out how long a given segment's going to take. But that's all right.
So still like one more thing for the partition. The partition is from a logical perspective or from a physical perspective?
And when I can hear logical and physical, immediately my mind goes to the 3 layers of database design.
Mhm.
The top layer is conceptual, and then the business analyst would be doing that, or a solution architect. The next layer down is logical, meaning all of the data and attributes are perfectly normalized from a structured perspective. So that's usually a solution architect doing that. And then there's the physical layer where the database administrator is assigning tables to table spaces. Okay, so that's where the physical layer comes in. So, and as I described that through to stage that as the reference point, what was your question again?
My question is, I try to understand better of that partition word here. The partition means the partition from a big data perspective. I want to know, because I'm confusing. I don't know. I want to know it is from a logical perspective or from physical perspective.
It winds up being physical.
Physical.
Just in the same sense, even in the relational database world, it winds up being physical. And usually is not represented at the logical level within any relationship diagram or any type of diagram. So it's kind of like with indexes. We don't really represent indexes on any type of logical design. It's more, the existence of partitions and indexes is a decision that the database administrator takes and applies. If you get a solution architect that knows about those types of objects and entities, then that person will do it. But database administrator at least. All right, so big picture. You look through this, there's 2 different steps for Hive here. Building schema using Hive, and then data queries using Hive. Right. So, whereas Pig just says, give me a file to chew on, and I'll transform it and output it. And it doesn't build any schema. The schema is intrinsically part of the transformation that's happening inside the Pig script.
So actually, Pig is working for Hive to load data in the table.
Correct. If they can get the data molded or transformed into a structured shape that Hive can be content with. So that is one of the roles of Pig, is to be that front end to transform data so that Hive, any scripting written in Hive, meaning SQL Hive, can be used analytically. Okay. All right, so install stuff, I don't have to worry about that unless you want to look at some dependencies. Let's skip past that. All right, so I mentioned managed tables and external tables. We touched on that last week. So do you remember the answer is not on here? At least I don't think it is. The answer is implied, but my question is, which of these is it managed table data or external table data that gets deleted when the schema gets deleted?
to, isn't that one of the tricks to
table
get that
has to
structure?
be in the storage that directly controlled by the Hive. And the external that is out of the storage of the Hive. Besides that, I don't remember it.
Right, so,
Hive's very structured, right? So if you lose the schema, it's the managed.
right, so you have the concept of managed tables and the external table. So if you just draw the table here. Okay, so if I,
Oh, the external table is for the schema. Managed table is for data.
right.
Right?
Right.
Ah,
And I always have to look at this because I always say this like every 6 months, so I gotta make sure I don't make the simple off by one mistake, since there's only two. Yeah, so the external table. Go ahead and say it again.
The managed table is for data.
No? So both of these have schema, and both of these have data. So that
But
is,
I think the one strong thing in my mind I remember is the managed table is in the okay, let's see. External table actually is out of the Hive storage.
right, so the external table points to the data. So if I get rid of my external table in Hive, if I say drop table, that's what we're talking about here, drop some table name. So
The drop table, the data is still there.
right, drop table X. If I go across here with the drop, data stays.
Yeah.
I think that's what you were saying.
Yeah.
Yeah, if I go over here, here, the managed table contains the data,
If you drop table, the data gone. Where's the table?
right? And when I say contains, I'm gonna put that in quotes because that's not technically the way it's implemented. But the idea is the data is gone. These are intrinsically associated with each other. So this is supposed to be an arrow right here. This thing that looks like an E. So drop table. Then one of these two conditions happens. Do that blue. So a quick little table to help see what's on the slide.
So, okay, to help myself to understand, the external table is just like a view
Yes.
schema. The managed table is the actual table.
Yeah, from an Oracle perspective, an external table behaves just like a view. You can delete the view and all the data is still there.
And then it is true in the big data, you cannot delete the managed table if there's an external table there.
They're independent of each other. Managed table is not dependent on an external table. External table is not dependent on a managed table.
But you remove the data. If you remove the managed data table, and then the data referenced by the external table is gone. And then external table is point to.
Okay, so yeah, let me take what you're saying and adjust the word slightly. With the external table, if the underlying file stored in HDFS that was put there by Big, for example, if that file is deleted, the data's gone. The schema is still there, but the data's gone. So it works in
But
reverse.
you are able to do that, but in the Oracle, you cannot do that.
Right, in Oracle, you can't accidentally make that mistake, you know, Hadoop you can. So we'll play around with that and see if there's some constraints that can be configured to safeguard that type of situation. I don't remember if there's a constraint for it. But think loosely coupled, loosely associated. Yeah, external tables means there's a schema loosely associated to the data file. All right, so the item that's not explicitly mentioned in here is the diagram that we did on the board last week. So just to refresh our mind and do this from a review perspective, how is Hive configured? And I think there was something further down in here, but it's not showing up yet, so just glance. Yeah, it's not. All right, so what is this Hive infrastructure in Hadoop? So first of all, where's the metadata stored?
External table.
No, managed table and external table are logical concepts.
Okay.
Hadoop.
No.
Actually,
This is why it's a little bit tricky, because the answer is not obvious.
it's the metadata is defined in your big programs or your Scala programs. The description of each record.
What you said is true, but thinking in terms of Hive itself,
Oh, Hive, I'm sorry.
Hive has a metastore. That's technically what the word is.
Right.
The
It-
metastore
it is
contains
used-
the metadata, which is the description of the tables.
Right, it is,
Columns.
that's the metadata of each external table is actually the column names
So that's
that we
true.
have in each file.
But where is the
Where is
metadata?
the
In the data, it's the very first, it could be in a
Where is
separate
it stored
file.
though? Where is it stored? See, nobody remembers that from last week. So where is the metadata stored? After today, you'll never forget.
Store in the memory?
No.
No, it's actually a file. It's a
HDFS.
store where we have the data stored in the same place as the data exists.
HDFS, no?
Yeah.
No.
I was really heard. All right, so. So Hive metadata is in an RDBMS.
Yeah.
And I gave you, last week I gave you the name of the default one. So what's the default RDBMS? It's an open source kind of lightweight database. I think Kentucky Horse Derby.
Derby
Derby database.
Survey database. Yeah.
Right. This is the default one.
Yes, you talk about that.
Okay. And there's like a dozen different databases that can be
But
chosen.
that's the default for
Right. So can you?
So Hive by definition
MySQL.
brings that with you. Or when you install it, that gets installed.
Yeah, it'll bring Derby with it,
But
but
if
that's
you want
all.
something else, you have to
Then you're on your own. You
link
gotta
it.
configure it, do the installation, and
That
set up the
tells
associated.
Hive where it's at.
Exactly. So the metadata for Hive is in an RDBMS. So Hive is this strange composite, this strange infrastructure thing. So if I've got HDFS down here, and I've got various data files, whatever, and using the terminology that we had over here, Now the external tables, I can have an external table defined up here. So external table schema that's referencing, you know, like these files over here. Okay. So there's an association that's going on here. And then I can have some managed tables that are over here as well. So the schema for the managed tables is also in the RDBMS, just like the schema. And the schema is exactly what Sergio said earlier. It's the columns and the table names and the data types of the columns, etc. So for the managed tables, it can be like this one and this one, for example, would be a file that's part of that. But since these black terminated lines are data files known only in the RDBMS,
If you lose that link,
and I can't go through the HDFS to really find it. There's probably, I'm sure there's when I say that, I'm saying from a pragmatic user perspective, I'm sure there's a way to go under the hood and nail the file and get rid of it. But from an implementation perspective, you know, just conceptually, anything that's a managed table, it has its own files, and if you get rid of the schema on the managed table, these two data files go away as well. That's freed up memory on disk. If I get rid of the schema from an external table, these three blue files are still going to stay present, because those could have been written by Pig, and you know, Pig could care less what Hive is looking at. You know,
Okay,
you've got you as the developer, as the person doing the programming, needs to be aware of whether you're working with a managed table or an external table.
Now who write the black table in HDFS?
That'd be like Scoop. You know, these are
Relation.
What's the command now? If you say create table from table XYZ, think of it that way. You're creating a table from another table, but it's a creation command that's done strictly through Hive. The managed table is done strictly through Hive. You can't create a managed table where the files came in through Pig.
Okay.
Okay, so that's why there's.
Well, can you please repeat that one?
You can't create the data
managed
files for a managed table directly through Pig. You can create the data files for the external tables directly by Pig.
Okay.
Because the schema is loosely coupled to the data. For managed tables, it's tightly coupled. In order to control that tight relationship, the data creation has to pass through Hive.
So then you just said the managed table is actually is created based on existing table in the RDMS.
Or it could be from Scoop, or I mean, it's not based on an existing table. The key thing is that it's created through Hive. So this black path, Hive, and then because Hive works with Scoop, it's Hive/Scoop. So it's Hive or Scoop created.
Okay.
And for the blue path,
So
this is you know, like we've been talking through Pig, so this is like Pig created this.
Or you can translate it existing table, right?
All right, so it goes more like this. So the access, you have 2 points of access, one through Hive and one through some external tool like Pig. Doesn't have to be Pig, it can be something else. In the managed tables, it's only Hive and Scoop. You know, the tools that are explicitly SQL oriented.
What about Impel?
Yeah, Impel is on there as well.
Okay.
Yeah, go ahead.
Yeah, where would you use managed? What is the example or use case where you use the managed table versus external table?
Managed table would be it kind of goes back to the roots of why big data with Hadoop came into commercial prominence. It's the managed tables would be there for augmenting existing data warehouse analytics. So Hadoop provides a lot more processing capacity, a lot more storage capacity, a lot lower cost. So all you need is Scoop dropping information into Hive, essentially creating managed tables. And then Hive scripts would be, SQL scripts would be doing the relevant analytics, aggregating data, summarizing it, whatever the script is oriented towards. Then usually sending the results back to a relational database management data warehouse. So think of the Black Path as analytics offloading from an RDBMS. And the Blue Path is more of, we've got unstructured data, that meaning the original form of the data is unstructured. You've got to get it into a structured form. So something like Pig needs to transform that data and get it into a structured form.
So the Black Path not necessarily has to be from the RDBMS, right? It's as long as it's something structured, as if like a structured table that Hive can understand that it should work, right?
Yeah. So I'm answering the use case question. The common use case for the Black Path is going to be in a collaborative data warehousing environment where part of the analytics is offloaded to.
Okay, thanks.
So for the scenario, if someone want to replace the data warehouse with a cheaper solution, then we can directly use the Hive and then write to the HDFS.
Yeah, that would depend on where your investment of dollars are, whether there's a business case to do exactly what you said. That's the part that's tricky. Because there's already a huge investment in the existing enterprise data warehouses. So you don't walk away from that very quickly at all. There's a lot of reliability that's already built in terms of that warehouse already supporting the decision making that's there. So it would be a very gradual offloading of analytic capabilities and functions to Hadoop. If the chief technology officer decided that we're going to migrate our entire data warehouse into Hadoop, they'd have to do that carefully.
Yeah, because there's a business going on, and you need to expand your data warehouse.
Right.
And then the cost comparison come up.
Right. So this is the unstructured data coming in. You transform it to structured. This is managed table. This is already structured data coming in. Okay. Now, one thing to keep in mind is I'm giving you the general use cases. The entire Hadoop environment is so loosely coupled with each other, the components are so loosely coupled with each other, that it's easy to find abilities to go around the general use cases, to bypass or skip the general use cases. That's something to be aware of. This is the nature of the use cases. All right, so let's start getting into a few commands here so we get used to the performance a little bit. I gotta see how this is going. as well. A lot of these, well, not that there's a lot of commands here, but these are the typical commands here. So go ahead and start running some of these commands that are on page 107. Yeah, you have tables already present. You don't have functions available because we haven't loaded any UDFs here. So obviously you can't run that one quite yet. On slide 107, to do the annotation of the pages. You should be able to be in your environment.
What page are we in?
Page 107.
Yeah.
Okay, I'm just going to put my other terminal windows to rest here.
There are some functions built in
There's quite a few functions.
it.
So if you go into Hive,
Okay, I remember I loaded these tables last time.
correct. This one takes a little longer to load than pig. This should come up usually faster.
The Hive and the what? Another of commercial one called?
Impala.
No, it's a Beeline.
Oh, Beeline. Yeah, the other interface.
Yeah, they are pointing to different location, right?
Yeah, Beeline's more for a server-oriented environment for Hive. So Hive can be installed on a server, and Beeline is the interface to be able to get to that Hive application, if I could use that word. So I forgot to try the log properties, so you might see some annoying information messages here. Let's see how that goes. We'll only be doing this for about 30 minutes here. Okay, there we go. All right, so if you do show tables, so show tables is going where? Based on the diagram that I put on the board? What is show tables accessing? Yeah, the meta store. Whether it's, in this case, it's MySQL is what this virtual machine is configured for. So I see these tables here. These are the tables from tutorial 1. And if you wanted to look at any one of those particular tables, like customers, I'm using semicolon at the end here intentionally. Fortunately, they didn't have the same any notation for a command. So this gives you the basics of the column and the data type. So you can hit up arrow, bring the command down, take a look at extended. All right, so extended makes it is really messy to look at. Okay. So, but what's in here? Detailed table information is what's being shown underneath.
What was the command line?
On page 107, there's a command extended. Let's see if I can make all this fit. Okay, so this fits. Made my window a little wider so this all fits in here. So basically, extended gives you the same information is described at the very top, but then it adds the detailed information. So you can go through this and you see that there's a lot of detail in here. It's really dumping out all of the metadata about this particular table. So there's the obvious thing of what is the table name.
Cool, it gives the HDFS location,
Your eyes are quicker than mine.
about third line down.
Third line down? Yeah,
Fourth line.
I know it's in here somewhere, right?
There's zip code and then a couple to the right.
The
Location.
URL, right, you're talking about?
So
It gives the quick start, that Cloudera 820 user high warehouse.
That is the URL.
right, so
I don't think
database
it's a URL, I
name,
think it's actually
owner,
in the Cloudera, in your HDFS.
storage descriptor. Okay, so when we get into the storage
Well, it is
descriptor,
URL with a HDFS location.
Avro, this is how Avro can access.
Averill, where's
Yeah.
that? Excuse me.
so I'm not gonna go through all of these because this is a lot of stuff to put in there.
Avro.schema.url.
But the main item that you see here
What line
is
is that? I
field
don't
schema.
see it. Oh, yeah.
Okay, so field schema starts here. So you see columns right here. There's a storage descriptor SD that has the columns. So every time you see a field schema, you've got a columns identified.
What?
Here's customer ID. Here's customer ID. Right? Go to the next field schema. Customer first name. Customer first name.
Oh, he said, can we have a better display of this extended, like the SQL in the, like the Oracle, when you describe a table, it give you a nice display, and this is like, whoops.
Right. This is like the duck command, only a little bit worse.
So we don't have a other way to make it more like human readable?
I'd have to look at it. But if you let your eyes scan for field schema, that gets you past all of the columns here.
Oh, there it is.
Here's what Pat was referring to. Location in HDFS happens on the 6th line down, 2, 3, 4, 5, 7th line down here.
But Joe's right, it looks like a URL. When you,
Correct.
but it's actually in HDFS, and in theory, go there. Maybe. How do you get to HDFS?
Oh my.
So this is HDFS because remember, this is a networked database, distributed storage. So it uses a URL in order to get to the locations.
What is the beginning?
HDFS.
So if I read this, the whole down extended, okay, I want to associate from where to where, for example, let's see,
This is table.
okay,
This here is columns, right over to here. This is all columns. And then this is HDFS specific information and job oriented information. So go like this. So it's format and storage information, let's put it that way. Number of buckets, I don't remember what that is. It's not compressed. It's using a Parquet format.
okay, this extended one is not like expand the description for each field.
This is adding more detail about what's actually stored in the metadata, in the metastore. So think of it as in Oracle, I can get from the column called DBA underscore cols, COL, or it's actually table cols, tab columns, I think is what it actually is, the exact name. I can get this output if I just select the column name and the data type. But if you go into Oracle DBA, as Oracle DBA, there's another like 20 columns of information associated with each column. There's like 20 columns associated with each table. And so there's a lot of additional parameters similar to what you're seeing here. And when I say similar, I mean that there's details about physical storage and physical management and size management.
You're talking about the $8 or something information or?
Yeah, DBA underscore, there's the DBA views.
There's a user underscore something, there's a DBA underscore something.
Exactly.
Okay.
Yeah, so whether you look at it through the user views and through the DBA views in Oracle, you're going to see a very rich set of metadata that is very comparable to this in terms of the number of fields that are present, meaning the number of columns that are present. Okay, so Surday, I need to start getting used to that. This is serializer, deserializer.
What's the command? Or what? Surday.
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 Serializer, deserializer. What that is.
Okay. So the idea of the big data arena is I've got data coming in that needs to be maintained in a serial fashion. So I've got data that's coming in serialized and getting stored. So I can serialize data and deserialize data. The terms are associated with more the concept of pipes than streaming, but closely related to streaming, more specifically related to data flow pipes. So we'll be touching into
What's the
that.
difference of the consequence?
The main thing for take Avro as an example, okay? Avro is a file format that's independent of language. So in the same sense that Java as a programming language is created to be platform independent, okay, Avro is created to be language independent. All right, so in that sense of a very high level abstract description, there's the sense of serializing and deserializing Avro files in the context of whatever programming language is actually being used to read and write that Avro data. Okay.
Because some languages use different data types, but internally they can be represented the same way. I mean, you can call a char or a bar char. So there has to be a way to represent those, and that's what Avro comes in, I think, right?
Exactly. So, this Hive and the discussion of what Hive does for us gets us right on the cusp of working with Avro. So one item to do for next week is to read through the Avro and Parquet chapters in your Hadoop Definitive Guidebook. So if you go to the beginning of your Avro chapter, which is chapter 12, there's some good tables that say exactly what Juan just said.
Avro is only for the big data.
It's actually generic. It came into existence because of well, I shouldn't say it became into existence. It did come into existence, let me see. The guy that invented Hadoop invented Avro. So it came into existence in order to provide
The generic protocol.
right, the generic description of data. So if you look at page 346, 347, and then 348, that's what we're talking about right now. This is in your Hadoop Definitive Guidebook. So 346, Avro data types. They're listed on table 12-1 as null, boolean, int, long, float, double, bytes, and string. Then there's some more complex types that are shown on page 347. So there's an array, map, record, enum, fixed, and there's one more, union on the other page. All right, when you look at these types on page 347, those types are all JSON. So So when you look at that notation on page 347 of the Duke definitive guide, you've got curly braces identifying the data, and then inside the curly braces, for example, the top of the array, you've got type, and then array items and log. All right, so that to the left of the colon is always the key, to the right of the colon is the value. When you get down to fields, and there's a record, for example, and you have square braces. In JSON, the square braces are a list. Okay, so Avro is using a JSON representation of the data that's stored in it. The key thing with Avro is that, and this is in your book if you read through it in the first couple of pages or so, is that it provides for schema independence. Okay, so that's the main thing to know about it. Schema evolution is the term, and Oracle provides support for this as well, so this isn't just a big data thing. The general problem of releasing your software, say at the beginning of 2015, and then adding some columns later on that you need that are relevant to your application in the following year in 2016 or 17. You know, it's like, what do you, will the old application still work with the added columns? If the information is being handled in Avro, the applications will still work. Okay, it doesn't matter if you're reading, if a new or old application is reading the new or old schema, it'll still work. There are some constraints there, but that's the idea. It's a mild constraint. So if the new schema is there, the old application will still work. You know, just skip the column that it's not familiar with.
This would be the equivalent of XML DS definition schemas.
I don't know the XML definition schemas.
You know, like when we were looking at R.
Yeah.
Or I'm sorry, SOAs.
Mhm.
It was a way of defining the data through XML.
Right.
So this would be similar,
This would be similar but more advanced.
more advanced.
Because it's specifically focusing the data, this Avro data format is focused around keeping the clients, you know, the applications independent of the data schema changes. So if I have an Avro library linked in with my Python program, or if I have an Avro data set that's being seen by Hive, the Hive environment with SQL and the Python environment will be comfortable reading extra data that the application is not expecting to be there. It's not going to choke up or anything. And it can also write out data and leave null values in the added columns automatically. The library will take care of that. So the application developer does not need to pay attention to making the application itself be in lockstep with the evolution of the schema.
So that means to make it forward compatible?
Backward compatible as well as forward.
Backward is always considered, but here it actually also make it forward compatible.
Right. Right. It's forward compatible. So this concept of schema evolution support is something that Oracle's had for probably 6 to 8 years at least. It's been around for a while. It may have been since the 90s. I forget when Oracle introduced the feature. But it's at least a decade old. Let's put it that way. How well it was implemented is another question, separate question. All right, so this is the concept of Avro here. If you go into page 348, then the specific thing that we were talking about in terms of mapping the Avro data type to a Java data type or some other data type in the language, there's a table there to help you know what that mapping is.
Did you see Oracle introduced this is more than 5 years? Why when there's a database upgrade, and then the application also need to be upgraded if it can support forward compatible.
Yeah, so it depends on whether the feature is enabled in the Oracle database or not. So it's not there by default as a feature to be used. But it is present. Okay, so Serde and Avro, they go hand in hand. Avro is one of the file formats that can be serialized and deserialized. Get into that more next week. The serialization library.
And the survey is from which page?
Serde, if you look at it in the index, Serde came available 0.9, and we're running 1.1. So if you do a Hive space dash version, you'll see our version number is 1.1. And in the chapter where we are at, chapter 12, it talks about serialization and deserialization right in the very first page.
Well,
I thought it was the first page. Here's the second page. Yeah, it's on the first page. On page 345, it talks about serialization. Just from a high-level quick look. If you want a more in-depth look, then you start going into page 349 and a few other places.
okay.
So that's a topic all by itself. So we'll just say, put that on your radar screen. Those are some blanks that we'll fill in as we progress. Okay. Now at the very bottom here is where you see table type manage table. Okay, at the very end of the detailed table information, you get the answer whether you're looking at an external table or a managed table. All right. So introduction into Hive, a little bit more hands-on though. All right, show functions. I don't remember what that provides. Just go ahead and type it in and see what you get. As I'm expecting, it shows the UDFs. Here it shows the UDFs that are present with Hive. Your own custom UDFs that would show up. I believe would be in this list as well. I'd have to check that out, double check. The idea of adding user-defined functions that are of interest to other people is perfectly fine for Big and for Hive. You become a contributor. So if you go look through this listing of functions, this is everything that's available. So current date, etc. Just because I'm always curious. So if I say select current date, see if I read that correctly and didn't make a mistake. Yeah, I just read it, did it quickly. It's current underscore date. Just the underscore. So in SQL, this is select the sys date from dual. Okay, in this case, it's select current date. So functions are available there. If we just say describe function, and since I ran current date, describe function, current date. strings on this. Yeah. So you need to put your function name in double quotes. So describe is simply a very cheap way of doing the help.
You need to put in a double quote?
If you're doing the describe, you do.
No. Actually, I didn't. It's still give me the result. Am I just lucky?
Mine complained. I wasn't expecting it to complain. But it gave me an exception.
Really?
Yours didn't? So I typed this in right here with a
Okay,
semicolon.
let me type it exactly.
Is yours slightly different? Like no
Yes.
semicolon?
Describe function. Which one then? Current date?
Current underscore date.
Make sure I. Let me copy this. Make sure I didn't make a mistake.
Right, so if you get over to page 162, there's some really simple, getting used to Hive. That would be handy.
Yeah, actually, this one gave me the exception, but what I did for the other one is describe function Mary underscore pop. That one didn't give me any.
Does it something path?
That's interesting.
This one you're saying? Our pop?
Yeah, that one. Can you try? Oh, small, I think. Matter?
Yeah, excellent. Caps key. Yeah, interesting.
I pick out one did. You pick out one.
Yeah.
That's interesting. Maybe because the length of the function name?
Who knows? I'd consider that to be one of these noisy bugs. All right, so if you go into page 162, let's do a couple of table operations. So DEL, like we said, is supported with Hive. Nothing fancy here. It's the same commands as what you'd see in normal SQL. So if I create a table X, it has a
162.
column int, sorry, it's not 162, it's 108, 108. I got the old page here. So we create table X, int, and here we should look under the covers a little bit, because this should wind up being a managed table. So you can double check that. So we bring up the terminal window.
.857 seconds.
For you,
Much better than me.
much better than me.
Oh, my God. I
You
thought
are
I
the
was paying
champion.
15. I'm not complaining.
Mine is only like 2.8.
You're just rocking.
Oh, we forgot to look at your so how's your machine, Sergio? How's the performance for these high things?
It completely changed after I deleted the one session of Cloudera, and then I reboot the machine. It went back to
Really fast?
Yes.
Okay,
Not really fast, but it's
reasonable.
acceptable.
All right, so, Joe's the winner at 2.8 seconds, probably.
2.86, you can put that. 857 is 86. 2.86.
And Pat had
15.
15, I've got 56. We use this to keep track of what's going on. How is your machine?
It's working,
What's that?
it's working fine, no more problems.
What's your time
For which one, I'm sorry?
for like a crate table, something simple like this?
Uh,
I have a question. Is there a way from a command to get into the HDFS directly? Like, so
Yes, the answer is yes. So you're talking about Hive or Pig or both?
from a command, I know from Hive and Pig you can't, but like, I'm used to a shell command. I want to be in the HDFS, not in. No, okay, there isn't. Yeah, I fought that and didn't get anywhere with it.
Right, yeah, there's no way to get into it because the only way to get into it is
File
this-
system.
This.
But then you
command
have to
here.
give it something.
That's very interesting. When you do the select, if you put this in different line, select star and from different line, it take much shorter time than you put it in single line.
Really?
wow.
So you run that a couple times to make sure?
The book shows the difference, much quicker, and mine is also give the same result.
Well, that's interesting. The next time I ran the create table, I dropped table actually, took 0.388 seconds.
It only took 2.3 seconds for the create table.
Okay.
Even
That's
faster, faster than mine.
2.3 seconds is a lot.
Yeah.
I use Watt's machine. Next week.
How much was yours, sorry?
I didn't test that.
Mine actually took longer on the multi-line thing, so I think it's just luck of the draw.
Okay, just so we can connect along the line of what Pat was just saying here. So what's actually happening under the hood here? You go to Hadoop and list out what's in user Hive warehouse. My machine's gonna be running a little bit slower than yours.
Doing that, let's see.
And this name I got from the detailed table information right here. So it said, here's the port, and here's the domain. And we're using HDFS to access it, and the it is this path. So,
Hadoop, FS.
so I give myself a little bit more space here, just rerun the command. You can see that the table that we just created, X right here, that shows up at the bottom. And these other tables, order products right here and orders and the other ones above it, those are what Scoop provided through the tutorial. Okay, so this is where your files are at. And remember in the detailed table information, it showed the MK as the format. And as Yukiko had pointed out last week, if I go look at, and I'll just choose X because that's one I just put in. It's a directory. And so there's nothing in there right now. If I choose something else that has data in it, like customers we looked at.
I dropped it so that it didn't show up.
Yeah, you went through everything without.
Yeah, I dropped it before doing this.
All right, so when you look at a table, it does have some data associated with it. There's a dot metadata file right here, and there's a dot signals, and then there's the actual data file itself, which is like a Parquet format. The Parquet, you know, was being used somewhere around in here. Let's see. There's Avro schema, what is it? It's a snappy compression. Parquet was out here in this location. The output format would be the Parquet right here. Okay, so you can get information about your output, about your files from this hard to read detailed table information. It'll show up where you're actually storing.
What was the command you ran? Oh, customers, all right.
Yeah.
Just file system protection, oh, that's there. All right, where else can? The interesting thing was when I did that on X, it came back with nothing, even though I had created the table.
Yeah.
Drop it, right?
No, I hadn't dropped it.
You haven't put anything in it. So
And, well, I did have one field, but there was
there's no
no,
data. It's only metadata that's been created.
okay. Ah, yes.
Insert,
Metadata signals,
do insert.
with Parquet.
Yeah.
But there's two Parquet files in there. Cool.
I don't remember the exact syntax for insert or even whether it's even, let's see, where is it?
You create table, and then where is it?
This will be interesting.
So insert comes a few steps down the road. All right, so we're at 15 minutes to. I'd like to, why don't we do just a quick overview of the weather information? As I said, I want to get into that so we get a feel of it. So let's touch on that. I gotta look at this performance on my machine. It's just gonna be slow. It's gonna slow us down. We've got
So we're
started
closing
with this.
Speed up pick.
So we've gotten started with looking at Hive. There's a lot more information to go through here. Go through it. What's in the slide? What's in the slides? Run these commands and see what it's capable of doing. When we get up to page, let me do the math here really quickly. So we get page number.
I did a
When
cat
we
on
get to
that Parquet
page
file.
123,
Finer.
yeah, when we get into, when you get to page 123, that's an interesting stuff kicks in. Everything before that is pretty much boilerplate stuff. So in order to go through this expediently, shall we say, it'd be good to start with page 123 and go all the way through. There's not anything in here that we haven't already talked about to some degree or another. Subqueries is the only thing that would be new information. A lot of the other, and then when you get to views, that would be new information, but still it's not rocket science or anything. Yeah, 123 going forward to the end of Hive, I'll try to answer the notes. And then I've got other labs and stuff that involve big working with Hive that I want to focus my time on next week.
You said 123 and then
123 going forward
going forward until
till the end of the Hive. You don't need to go all the way through the end of it in terms of running commands. So the probably need to stop at page.
Well, no, it's a lot.
Right. So I would just go through up to
173.
Go up to partitions. So partitions is on page 191.
What?
If I did my math right.
You already passed the map reduce. Map reduce is only 175.
I gotta see let me see if we got the same files. Okay, all right, go forward. We got 123.
133 is that.
Mm-hmm.
147 drop.
Yeah, you go.
150.
There you got partitions. Where's your partition?
Partitions, start at 157,
157.
I believe.
Oh, I'm sorry. I did know that. Way off.
157. Yeah,
Where does your partition start?
157, I believe is.
I didn't
Copy.
say
Go up to like 156.
156.
Yeah, there we go. Get the right page number here. I'll look to see what the differences are going to be here.
What? Mine's different from all you guys?
No.
Pat said something I didn't say the petition. Where is the petition?
157 had a petition.
Oh,
come in.
All right. So we
Stop before partitions.
stop here.
Okay. Perfect. All right, let's have some fun with weather data. We have 10 minutes. I want to take the user-defined function format that Joe had provided here. So we go in my email, get that out.
Is this guy coming? Oh, you're kidding. What happened? It's thinking.
There we go. All right, so here's the email thread, weather data for PigLab. I know Sergio had said he had worked on the advanced lab as well.
Which one? I'm sorry?
I think you mentioned that you worked on the advanced
Oh,
lab.
yes. Yeah, I think I completed all of them.
So if you want to send out your results, and I know Joe has a little bit more to send out, one of the key things to look for that
I ran on other one, but I didn't. I tried to put them in one pig file, so that just call once and everything will be there. I have this individual lines somewhere already, but I didn't put them all together. The last step is I want to have the UDF working perfectly, then I can create a one pig file.
Okay. All right, so let's see. So Yukiko had some information in here about how to consume the extra spaces. So there's different approaches people have taken. And because there's there's about 8 or 10 people in the class, there'll be like 8 or 10 different solutions. That will be similar to each other, but different languages, different ways of integrating. All right, so I want to do the UDF approach here.
To do the UDF, actually only this line is needed, and then in the PIC file, actually you need to do register.
I didn't get any data except for
This is your,
Sergio's. Anybody got anything for you? Or you keep, or it went in my spam
So
folder.
what I pasted here is start from import, the import CVS, CSV, and the import sys.
all right, this is all Python.
Yeah, the all Python, you put the copy paste this one, create a Python file, and then run it, but it does not work on the 2.6.
Oh, okay,
I run it in
that's
the
good to know.
3.5 that I installed on my computer, and then that works, and then generate the
data
output like this. What I did is actually I also separate the year, months, and the day,
Mhm.
so that it's after loaded, I don't need to do any like split.
Mhm.
I just need to fill out the bad data, and the rest of them I just can call the existing function and then generate a report.
Mhm. All right, so I think what I want to do is, how about if I'm watching the clock here. The we've got the email thread here. Go ahead and look at each other's work. I'll assemble each other's work into something that we can just walk through quickly this coming Saturday. But the email threads here, look at and see what people are saying.
Yeah, I can follow the same thread and then put my UDF
Mhm.
there for the PIC.
Yeah, and we could actually take that MATS Class Schellenberg account and just drop our files in there. That'd probably be the best way to do it. So we'd already started doing that. One of these guys.
So which account are you talking about?
This one, right?
Oh, class.
Schellenberg.
Okay.
Yeah, why don't we do that? Because then it'll be a lot easier for people to communicate with each other, and then we can contribute together towards a solution.
So drop in the drive, right? Google Drive.
Yeah, I'll create a folder for it right now.
That's the place I dropped the zip file, right?
So we put up a drive here. I'll make a directory under here. This is something I wanted to do with GitHub, so we can start it off this way. All right, so this would be and I'll just say projects here. Do projects, and under do projects, let's create another one. And this is yeah. We're focusing on Pig and Python here. If there is some Python, that's fine. If there's not, that's fine. But this is a so in here you can create a folder if you've got multiple
What
files.
was that, MITS?
So if you have multiple files, create a folder. If you only have one file, put your name in it so it's identifiable. I'll just drop the one file in here. And we'll be able to execute that this coming Saturday. Instead of having key slides coming
Yeah,
together.
Why can't I find
The
the Google
UDF,
Drive
the
again?
UDF, I tried on the 2.6.
Where is this from?
Okay. So this will give us a way to communicate here.
Wait, okay. Where the heck is it?
So you're under the MITS.
No,
Google.
that's where I can't get to it.
I mean, are you on the Gmail, for example? Which inbox is this for?
That's a good question. No, the wrong one. I choose, wait,
What's cooking?
I
I wanna see my
here,
solutions.
oh, is that it?
So we're going to, like, it's always loaded up
For
at
one
the
city,
top
for
there.
one state.
Oh, I'm in the-
for
I'm in
multiple
the-
states.
MITS, right, inbox.
Yeah,
Where
that looks
is
like
the
Yeah,
Google?
it's listed right here. So yeah, you just click
Oh.
on that
I didn't know.
3x3 grid.
No.
It gave you an extra thing. Click on the 3x3 grid, the upper right.
Yeah, I'm trying to, it's gone now. It's reloading, the whole
Yeah.
damn email.
Yeah,
Okay.
so as you're looking at this interface here,
The final solution is
Click on this
individual
3x3
Python
grid.
file. But
Yeah,
I don't
then
have
click on
final
Drive.
solution with the UDL.
and Drive will take you
Would be
off
there.
into
But you are the one who sent a new deal.
My drive?
So the
This
one I
tab.
sent on is the
this location here.
standalone.
Yeah, go in there.
What's the name? Mix.
And then underneath the new projects, click into that, and then
Oh, okay.
other big Python. And this is the area to drop a file in with your name. If you have a single file to drop in, or create a folder and drop in, or 2 or 3 or 4 files, whatever.
Oh, okay. I just send my solutions to Mix scale.
Okay,
You know.
I can drop them in here, or you can drop them in
No,
here.
no. If you could, that would be great.
Okay, I'll do that.
Yeah.
I'll do that.
Actually, I have for one city, for one state, and then there is another big script which is called test one. That's the one that handles multiple states. I mean,
Good.
multiple cities within a state.
MITS.
Okay, good.
What's an MITS?
All right, so this will get us going so that we can walk through it rapidly next Saturday. So next Saturday, we're gonna keep building our path here. So should be good. So I would like to think that we would be done with the pig and hive space, including the scoop with the Avro and Parquet files, et cetera, by the end of next Saturday. That's probably a little bit aggressive. It might overflow by 4 hours or so. I'll do a double check against the exam criterias in terms of what the exams cover to ensure that we're not missing anything by the end of next Saturday. If we are missing something, obviously we'll cover that in subsequent 4 to 8 hours. So any questions, comments at this point?
Where do we start?
What's that?
Question number one, where do we start?
Where do we-
Asking questions.
Oh, where do we start? In terms of, give me a little more context. Hive specifically, or,
Get ready for the exam.
oh, where do we start getting ready for
Is
the
that what
exam?
you're asking?
Yes.
Or are you just saying, like me, a
Oh.
wise guy? Where do I start?
More like the second.
The way, so you gotta keep track of what you're practicing, as I pay attention to what you're covering. So we looked on the first class at what the certifications were.
That's the first question. There seem to be a lot of different ones in Cloudera, and I wasn't sure what we were
It's
doing.
about 5 of them, 4 or 5 of them. All right, so we're doing the data analyst one first.
Okay, I'm gonna close this now.
So when you go to data analyst, there's a professional, there's a CCA, which is the associate, and there's
You
a
have to do
CCP.
CCA first.
So those two are related to each other very tightly. Yeah, not coincidentally, obviously. So they start off with this information that we'll be covering next time. So it's okay. And then there's more, about Hive and Impala right here. Just, we're barely touching on this right now, so next week we'll be extensively into this. The Impala is in your virtual machine as well. So whether you're using Hive or Impala, it's just a difference of What's the prompt say? Does it say Hive or does it say Impala? It's because they're both CLI.
They have identical functionality.
My sister.
They do,
Oh, why there are two?
because architecturally they're a lot different. Hive is slower, but fault redundant. Impala is faster, but not fault redundant, not fault tolerant.
So the Impala is also in our, what you mentioned?
Yeah.
If we type Impala, then we got it.
I've just taken that for granted. I assume that is the case,
Let me try.
from what I've been reading and all.
I give it a shot. Let's see.
Now there's something else with it. They'd have to look at it,
Oh, it's not directly in there?
right? Okay, so this exam is all Hive and Impala oriented with Scoop. So this CCA data analyst doesn't cover the pig, et cetera.
Doesn't do pig?
Right,
Oh, well, good.
interesting. So let me look at the CCP area. Go look at the data engineer.
Real time. Transfer state.
Right. So this is the area we're working on.
And that's in the CCP?
Mhm. So it's talking about formats coming in and you write them into HDFS or Hive. If you're going to write into HDFS, you're using PIC,
That was CCP data engineer?
right? CCP data engineer.
Okay.
So the CCA was restricted only to the SQL environment of Hive and Impala. So the CCP is broader than that.
Can you take the CCP without taking the CCA? That's the question.
I would assume so. So this is what I've always been focusing on. Purge bad records from the data set, deduplication, merge data. And deduplication is often big today. If you're getting rid of duplicate rows, what do you use?
Distinct, right?
Right, distinct.
No, it's not this thing.
Mhm.
Yes, that's right. We just saw that example.
Right.
But if there are duplicate rows, this thing, you need to group it and find the biggest row.
No,
You
this
just-
thing is like the sort unique.
You load it and then you distinct the data you load it. And then it will get rid of.
Once you have the data in
duplicate.
memory, you can do a distinct on it.
So from a professional perspective, I would suggest that people go, print this out, or put it in a Word document or whatever your convenience is, and then make this be the focal point of marking out, what do I need to know, what do I need to practice? I'll do this as well. We'll probably get about 3 or 4 variations that we can coalesce together. If you do want to get more detail on some of this stuff, go to Hortonworks certification.
To where?
Hortonworks.
Okay.
Now, obviously, it's not the Caldera environment, but when I have gone over to Hortonworks certification, they have a very, very precise certification. They have a much more precise definition of what certification means in their context. This is HDPCA, so I gotta get back on here. And so here's their certificates for Hadoop developers using frameworks like Pig, Hive, Scoop, and Flume. And that's what we're doing.
Which one are you going to? The H2, oh, right, but which one of those do you pick? I guess you gotta start with.
So the difference between this and what we saw with Cloudera is that Cloudera is using the general terminology. They're much more general in what they describe. So talking about ingest and egress. Ingest is bringing data in, egress is writing it out. So this HPCE mentions the specific tools as opposed to mentioning those terms. So if you went in and looked at this, it's really detailed on, let me do the view all objectives or exam data sheet. Okay, so this is what I was looking for, just in the middle. So there's exam objectives and then exam data sheet. So it means focusing on Pig, Hive, Scoop, and Flume. Data sheet, check this. Yeah, okay, check this. No, it was a little bit screwy the way they organize their terminology. It's like objectives. I usually think of objectives as being a really tight short list. And their idea of objectives is, oh, here's all of the details.
So where did you go?
So this is under, I'll send out this link here. Well, this has a good list of very specific, examples of ingestion. So if I'm going to ingest data, meaning bring data in, I've got scoop import. They mentioned egress as well, which is exporting. So I've got the Flume, I've got the Scoop and the Flume covered here, and some freeform with regard to Hive transformation. I'm working with Pig and Hive together. Okay. There's another page on transformation right here. So a lot of this we've already touched on, just adding the Hive component to it. So I like Hortonworks description because it's much more concrete and not so academically stated. It's very concrete, like this is what we need to do. So there's a word on certification. Where do you start?
That's where I start.
This is the best place to start, really. So even though we're aiming for the Cloudera certification, that's what Paul advertises and all sort of committed to that. But the certification details of the exam are very poor from Cloudera. Much more clear from Hortonworks. That's ironic.
Okay, Dan. Thank you very much. Have a nice weekend. Have a nice weekend, guys.
Catch you a little later. Next week.
Patrick, Joe.
Yeah, I'm with you. I'm getting out of here myself. The clock on the wall says it's time to go home.
Yeah, so is my computer.
And I'm sure,
I've got my daughter's birthday party.
oh, you better get your, yeah, okay.
Putting chicken on the grill in about 15 minutes.
Rotisserie chicken?
No. Marinated.
Oh, okay. Yeah, we do that too, marinate those chickens.